What's up, goobers? Yeah, this is working. I don't know why at this point I'm still, like, paranoid that the stream is not working. Because it has worked, like, pretty much every time I have started. But I don't know, I just like to make sure that it works, every time I start, I guess, because, like, I don't know, if I, like, forgot to put on the microphone, or if, like, it's not actually going at all, and I've just been, like, doing things assuming everyone's been watching it, and it doesn't actually happen, and it's kind of awkward. But yeah. Okay, let's see, I guess, yeah, so some updates. On Sunday, I went to, I think, my first actually ever, metal show. It was, Hanabi, and yeah, that was really fun, because, I mean, I've been listening to, like, metalcore and, like, post-hardcore punk, and, like, I don't really listen to, like, normal or, like, classic metal, I guess, but, stuff like metalcore and post-hardcore and, like, pop punk and screamo and stuff, I've been listening to it for a while, but I haven't actually been to a concert or a show in that genre, so, yeah, that was really cool and fun. So yeah, I've just been listening to that, like, all day and stuff. I guess since I got back and, like, really rebuilding my playlists. And what else? I guess I'm gonna be dropping down my streams per week to, like, 2 a week instead of 3 a week. I'm gonna be dropping the Thursdays just since, like, I need to lock in again on, like, trying to find contracts and stuff. So yeah, I also need to fix, because, like, okay, so, totally unrelated, but, like, the chair, it keeps, like, disappearing behind me, because, like, it was calibrated, at first for, like, a different chair, that I was using when I cared about having the wrist track, or the waist tracker on, but actually I've just been not putting on the waist tracker, and using, like, head angle to, infer where the waist, is, which also takes into account, like, if I'm leaning, to the side or, like, back and stuff, or anyway. But yeah, but another thing is that, like, since it was on a kneeling chair, which, I should probably show a picture since I don't think most people know what those are. Okay, let me just Firefox, new tab, was it avatar button? Yeah. That's on the wrong screen. Hold on. Where is my screen view at? Why is that set to my top screen instead of the ultra wide? Okay, kneeling chair. So yeah, I have one of these. It looks like this one. I know, I like to change up the posture sometimes, but a really good thing about this kind of chair design is that, like, since there's no back, you can, like, stick, like, a waist tracker on your back and it won't get, like, blocked by, like, a normal office chair, but, lately I've just been not bothering to even wear the waist tracker, so I've just been using my normal chair, which is a, steel K-Sleep. But yeah, the thing is that, like, the automatic chair detection, it assumes I'm using a kneeling chair, and it makes some assumptions based off how my knees are bent, which are very tight in that chair, but, like, not in a normal chair. So yeah, I need to fix that. It's kind of been on the to-do list for a while. But yeah. Oh, I got a shirt, which I'm wearing right now, at the Hanabi show. Tour shirt. Which one is it? Because they had a lot of options. It was the one that had, like, the bunny on it. They have a lot of shirts, wow. But it's not any of these ones. Oh, there it is. It's low res, but hopefully that's enough to see it. Yeah, I like the shirt. It's cool. But anyway, okay. So, yeah. Oh yeah, I also am preparing for BattleBots in, like, 3 weeks. So, I don't know, I might put some Thursday streams back on if I can figure out what to stream that isn't, like, NDA or giving away, like, competitive secrets. That'd be fun too. But, yeah. Let's see. The water machine is online. Let me go clear my workbench a bit. I guess I need to turn that GoPro back on also. Okay. Turning on the GoPro. Gosh, that is a nasty looking work mat. I should probably wipe that down first. Do I want to use IPA or just water? I'll just use water. We're not doing anything crazy right now, and I'm gonna be catting. Anyway, okay, so, the stream today, I should probably show it after wiping off stuff. So, I use the OMNIFIXO Helping Hands, which I have been a big fan of ever since, a buddy of mine convinced me to get them. And I think it was actually at a, BattleBots, exhibition event a couple years ago that, I was convinced to do that. Like, he was like, you should borrow these and try them out and solder stuff with it, and trust me, you're gonna want to buy them yourself, even if they're like $60. And it's like, wow, that's kind of pricey for Helping Hands, but all the ones that I've had before have been like pretty crappy, and like I've never been like really happy with them. So once I tried that, I was like, oh yeah, this is probably worth it. Okay, that should at least make it not look super weird and nasty. Okay. So yeah, here is the tray for the OMNIFIXO, and that's not the only thing on it. So the OMNIFIXO is like just the system that has like these magnetic grippy things on them, and let me go zoom in on that. Okay. So yeah, there's plenty of like magnetic tray helping hand systems out there, but I guess this is what makes these ones different. So the ball joint that they have is magnetic, also, not just a way to secure it to the steel tray thingy. And so I find that it keeps like a nice constant pressure that keeps it in place just the right amount. The ones where you have like the screwy things, I find that they're not really consistent in how well they actually keep a grip on. Like sometimes it'll be good, and then you move it like a few degrees and then it's like super loose, and they also lose the grip over time a lot. And it gets to a point where like you have to over tighten it to the point that you're just like stripping like the wing nut or whatever. Actually, I should probably bring up a picture of like other helping hands. So yeah, this kind is the kind that I had a long time ago. And also, this base, even if it's like kind of heavy-ish, is like still way too small to actually be useful. Now I know that you can like just attach like a bigger tray or something, but yeah, it's just kind of weird. Like at least they should have like little holes in the base or something so that you can like screw it into like something. But yeah, I've just always found that these things, they lose a grip, and since a lot of them have like, it's like 1, 2, possibly 3-ish degrees, and then you have like this one here for rotation, it just takes like one thingy here in the chain to get like super loose to just collapse on you and really suck. And yeah, I just find that this design really sucks. I don't even know why like it's been around for so long and is like the default one, because it just really sucks, I think. But yeah. Okay, what else? Oh yeah, I guess so with this, you have only like one joint here. And since it's magnetic, I guess it's like kind of a consistent pressure, and they've tuned it just right so that it does that. And because you don't have like a lot of these going on at the same time, like one trick you can do is you can actually stack these. I don't do it that often, and like just the more links you have in a row, the kind of less reliable it gets. It's not really meant to be used that way, but you can use it that way. But yeah, I guess another thing is that like, oh, let's compare it to some other designs. So there's other, I've had this design before, and I think kind of the problem with it is that like, when you adjust it, you have to like kind of keep playing with it until it's at just the right place you want to be, because like you'll bend it in place and then it'll kind of spring back a little bit. And the magnetic stuff doesn't have this issue. And I've also found that like the connection from like the alligator clip thing has also, it also just tends to get really loose. And then what else? So I think the issue with this design, where instead of having like the plasticky spherical things, you have like just kind of like this gooseneck springy metal thing, is that like if you bend it too much, it eventually like kind of loosens too much and just loses its ability to stay where it should be. And it's also kind of got like an unpredictable, I guess, kind of an unpredictable amount of staying power, I guess. Ability to hold its angle that you set it to. And then something that a lot of helping hands just kind of have in trouble, have in common, that's like an issue, is that like these ones have the issue, these ones have the issue, these ones have that issue, is the pinchy things. There, a lot of them are using alligator clips, and even for the ones that don't use alligator clips per se, they still have kind of a similar issue. So the first issue with the alligator clips is, let's see, these are not alligator ones. Yeah, these are definitely alligator clips. Is that like the teeth marks on them, they'll just end up scratching like PCBs and like scratching off the soldering mask. And if you're like using PVC insulated wire, then like, especially when you're heating it up, it just softens it, and then you get like all these nasty bite marks on it. I don't really like that. And even for the ones that don't have the teeth on them, or have like the little rubbery pads on the ends, they still have the issue where like they have like this like kind of like pinching action thing. And so like if you're just clamping something like pretty thin, then like it should grab it fine. But then if you're grabbing something that's like thicker, like this, then it only grabs it from like the corners and just doesn't really hold it well at all. And that's unacceptable. And what the OMNIFIXO does differently, I know a few other systems do something similarly, so I'm not gonna say they invented it, but they did do a good job at implementing it where these are actually parallel. So as long as it fits at all, you have a nice, even, and parallel like clamping thing, so you can like have this like really, oops, that's not a good demonstration of holding stuff well. I mean, it is cylindrical, but yeah, it can hold something thicker like that, just as well as something thinner that is so thin I'm having trouble grabbing it, like this. So yeah, that's what I like about this system. There are some additional little features of it, but I haven't really used them. Like, the little magnet thing that holds it together, you can actually intentionally flip it around so that, like, when you're in... So, you'll see that, like, here, there's metal that goes out the bottom, and in here, metal does not go out the bottom, it's plastic that's touching it. So that's kind of the default. So when you do this, and I believe this is the conductive pad on it, you can actually take off these little thingies here, and then you can grip like some kind of pad or something on whatever PCB you're doing, or some wire, and then you can actually complete a circuit that goes, when you flip this upside down that is, you can actually complete a circuit that goes through this whole entire thing to whatever pad or wire you're clamping, with the insulation taken off, of course. Although, usually I don't do that. I've actually never done that before. But, yeah. Yeah, I've bought, like, so many helping hands over the years that I'm pretty sure that it actually outweighs the cost of the OMNIFIXO, but, like, I just don't see a reason I'd ever replace this thing. So, yeah, it's like, it's not cheap, but I'm also never gonna buy another set of helping hands unless I just need more OMNIFIXO. But yeah, something that's also really nice about OMNIFIXO specifically, that doesn't actually really have to do with its design though, is, let's go to printables. That's not how you spell it, but, okay. So, if we go here, and if we type in OMNIFIXO, you get, like, a ton of models, of just kind of accessories and carrying cases and stuff for it. So yeah, this one holds a Pine-Sol with the shorter tips, which, my favorite tip finally died, so, I just actually upgraded to the short tips. So I can actually use something like this now, because the problem is that a lot of these cases are meant for the Pine-Sol V2 in their tips, so I can't fit the older ones in there. But yeah, it holds the clips in there right in place, holds little magnets, a thingy for solder. I have a bunch of other ones. This one just kind of holds them loose, and has a supports a different soldering iron. I think that's the TS80. You have ones that have like entire, like, you have the scrubby pad built in. This probably has like a flip out stand for soldering iron. I don't see it, but I know I've seen it integrated in a lot of these designs. Yeah. Oh yeah, I think this is actually the design that I use personally. Yeah, this is actually the design that I use. And so, what I like about this one is it actually doesn't have, like, any dedicated slots except for the little magnet things. It is definitely bigger than the other ones. And I mean, having like all the little compartments meant specifically for everything to go into is pretty neat, but like at the same time, I often cram like some extra wire or like some extra solder or like a bunch of like heat shrink wrap or something in there. So I think kind of the problem with like having all those little compartments is that it technically is also kind of a waste of space when you could have been shoving other stuff in there. And if you change the configuration of what you're packing in here, then it actually kind of limits you on what you can throw in there. So like, yeah, let me just toss together, like, here's the Pine-Sol with the short thing, and I think the entire thing actually fits in there now. You used to have to take it off when I had the longer tips on there. But yeah, I can just toss that in, toss some like electrical tape, toss some solder, toss some more solder in there. Can take some other Pine-Sol tips and just put them in there. I can take my flux pen, just toss it in there, and then The only things that actually have their own dedicated slots are these magnets, because they help shut this in place. And then have a nice portable unit, which uses the OMNIFIXO baseplate itself as the lid, and kept in place with the magnets. But yeah, so that's why I really like this thing and think it's totally worth the price, because I have not felt any urge to replace it with any other kind of system, but I do feel like that it's still not 100% perfect, and there is an add-on that I want to add to it to improve it. And so, let me get, yes, like, we gotta look for like some boards of various sizes. Oh yeah, Arduino Mega is pretty big. I'm just digging through like a bunch of microcontrollers. Yeah, this is I think an Arduino Nano with a USB port ripped off. We're not gonna be doing any like actual soldering right now. I'm just demonstrating. Let me go grab a blank PCB also. And you know, let me also get a XT30 or some other connector like that. Okay. Yeah, let's just toss this board in. I don't know if I have like any loose XT30s hanging around, so I'll just. That's MR30, close enough. Yeah. Oh wait, is this almost a blank PCB? Yeah, we'll just use this. Oop. Okay, so yeah, here's just a variety. Whoa, I don't know what the fuck happened here. Here's just like kind of a variety of different boards, and let me just snip off these wires from the MR30. Okay, so one of the limitations of this though is that like this is definitely stable enough to like hold like a single wire. But when you're holding an entire board, it's just not as secure in like each direction. And so you kind of need to combine like, yeah, if I'm just doing this and if I'm like trying to manipulate stuff with it, then like it can rotate a bit on that clip. You can kind of like put in a bit of a better place. And so often the solution is like use two of these, but like it's not until you have a third arm that really keeps it in place, because like here it can move in any direction, any angle, however it wants. Then here you're kind of restricted to like just kind of one-ish axis. And then once you have that third one, then you have like that triangle-based thing going, and it's quite in place. And then that leaves only one more of these for like putting a wire up here or something. And it's the same issue even if you're like doing something like an MR30, which it might be annoying to keep having to set up a bunch of I guess different fixtures for, or I guess repositioning it for like different wires and stuff, instead of like having it all in one thing. So what I want to make, originally I was just going to make something that holds a PCB really rigidly, but I think also maybe making specific things just like hold an XT30 or an MR30 or just whatever connector I need in the right place is think that's also probably gonna be helpful and probably doesn't need that much of a change in the design. Let's see, what else? So the OMNIFIXO uses these magnets. And so I've also got plenty of magnets from some like BattleBot stuff I've been working on, which isn't anything crazy. I've just been working on some like safety tip covers for the weapon blades, and they stay on using the magnets. But yeah, let me go to the bathroom. I literally just went, I have to go again. Okay, I'm back. Well, my trackers are not back yet. Let me turn this back on. Doop. But yeah, I think the idea is that I want to have a way to hold those like PCBs and connectors without needing, like, hold one thing just in place without multiple gripper things being used up, so that I can save those for like additional wires. So yeah. Now there are some good ideas that I've seen, though. It's not any of the ones on here. Let me see if I can search for them better. Oh, you know, actually, there is a combination of... So, yeah, this is actually a really good example. So I've actually never used one of these systems, and so just ignoring those arms and stuff, like, I'm sure that's fine for the light, for the ring light thing, but like, I already told y'all why I don't like those springy arm things. But it's... Oh my gosh, this website's annoying. I'm just gonna zoom in. So yeah, it's these little tower things that I'm actually interested in making that would be compatible with the OMNIFIXO base. I mean, OMNIFIXO base is literally just like a steel plate. There's nothing special going on with that. So it's compatible with anything that's magnetic flat surface. But, yeah, that's, I kind of want to work on something kind of like that, except instead of having, like, multiple little tiny towers, maybe it'll just be, like, one thingy, or just two thingies. I don't know. Going, like, with multiple of them actually does seem like maybe a better idea, just because, we can do it with, like, a bunch of them at once. But yeah, there's kind of multiple ways to go, because, like, for this design, it looks like that the magnetic tower doesn't actually move at all. It's, like, pretty simple. It just has a magnet and, like, these little grooves, so you just line up whatever needs to be lined up into those little notches, which are diagonal, so I guess it can accommodate different thicknesses. But there's another design that I like. It's this one, I think, where you have little springs, not you. You have, like, little springs You don't like those. Yeah. And so you can actually kind of compress it, and it does the same kind of like, I guess, parallel holding thing, instead of like using a spring-loaded lever to grab stuff. But yeah, I wonder if there's actually a name for those. PCB holder magnetic might be it. Yeah, this is a similar deal where we have these like notches, but it doesn't move around. This is one, I think, where... Oh, this is definitely one... Oh, you know, this is interesting, because it's actually using screws also. I might... Let me go actually make a new window just for, like, reference tabs. Just to, like, save ideas. Okay, I guess they're called PCB vices. This is one that I actually saw when I was, like, doing a bit of research for this project. Yeah, that one's pretty cool. And because I'm designing this to go with the OMNIFIXO, I can design it to be at exactly the right height that it needs to be to, exactly the right height that it needs to be to fit the OMNIFIXO clamps, well, and by fit, I mean, like, be at the same level as where the clamps will typically hold wires. But yeah, I'm not too sure if I'm into this kind of design where there's like these little needle points at the top. I don't think I'm going to be going that direction, but I see what kind of the idea is that you can put stuff, you can put it through the holes of like any PCBs that have mounting holes, but I feel like that's going to kind of raise the overall height of it, and there's nothing that's vertically keeping it in place. Yeah. I do wonder, though, if I want to go with, like, just if we want to have, like, just one thingy, that can hold a bunch of PCBs, or if we just want to have, like, 2 of them, or if we want to have, like, 4 of them, like, 3 or 4, 1 for each corner. And what I'm kind of leaning towards, maybe, is, like, kind of going the mill route and having, not, like, 4 small ones, but having, like, 2 of them that can support it from, like, either side of a PCB and can hold an entire smaller PCB by itself. Plus, I have all those bar magnets, which are really nice and strong and will keep it in place, and I just kind of feel like that if we just use, like, one of those, that, we should be able to get something that could hold an entire PCB by itself without it changing angles and moving around. But yeah. So let's open up Fusion and let me go get out like my assortment of like springs and probably O-rings and other stuff like that. Just since that helps. Where are they? Okay, here are the springs. We have both the pushy kind and the pulley kind. And, yeah, we have a bunch of different, thickness. I don't think thickness is the right word, but we have a bunch of different variants that we can work with. And I'm thinking the O-rings will just be good for, like, grip. Definitely better than, like, pure TPU for grip. And also keeps it nice and soft, so that it doesn't, like, leave marks or whatever on the, wherever we want. This feels like something that... No, I think M4 screw is probably about the right size for this. And I can't find my O-rings. They might be in a toolbox in the living room, so I might have to pause and grab that. Yeah, I think my O-rooms are not O-rooms, my O-rings are actually in a different room, so let me go grab those. Okay, I'm back. I found my O-rings assortment. My nice, cheap Harbor Freight, like what, $5 or so assortment of O-rings. I found retaining rings, which we're probably not going to use, but I need to have them anyway, so might as well take them out of that toolbox. And why are they all clumped up on one side of this thing? I need to sort those out, but that's a problem for me another day. Wow, I didn't know that this came with some gigantic ones. How the hell did they get in this mess, though? Okay. I just want the damn box to close. Okay, cool. Box closed. Let's put it up on the wall. Now I think about it, I'm actually not sure how I'm going to be using these. Because I was kind of imagining that they'd, like, kind of be gripping things, but then I realized that, like, there's not really a way to hold them where they should be. I know, I have some ideas, but at the same time, you could just use TPU because it's nice and soft and still compliant. And we can print it however we want, and honestly, that might probably be the way to go. But yeah. So, let's see. I think I just want to kind of like study how this design works. What I think is going on is that there's probably like a spring that lives in that base, and then you can just kind of pull this down manually, and that'll expose a little gap that you can slide wherever it is in there, and then the top is a fixed height, which works with the OMNIFIXO grippers being the fixed height that they are, well, semi-fixed height, because you can angle it a bit and like get a bit of that like Pythagorean theorem goodness on that. So yeah, you can make it a bit higher if you're using the tip of it and just angling it up. But in general, you have kind of like a range, a fixed range of height that you can work with there. But yeah, do I have any other magnet shapes? I have like a bunch of random magnets that belong here, but I don't think that any of them are the appropriate shape. I don't know where all my other circular magnets went. But I also don't think that they'd be strong enough for this, or as strong as I want them to be. And like, honestly, I think it's better to go overkill with this, with like something as big as Oh, that is really overkill. Something as big as this guy, which is, I think that is 10 by 4 by like 40 millimeters, I think. But yeah. So what I'm kind of thinking is just making something like this, except maybe like oval shaped, or like pill shaped instead of this like kind of cylinder shape. But yeah. Okay, so I think probably a good place to start with is oh wait. That didn't show any secrets, did it? Let me go hide that, because I don't want to give away any competitive secrets. Phew, we're good. Okay. Let me just switch over my Fusion account. Yeah, I was doing BattleBot stuff right before this. Okay. We are back. And let me go make a new project. We'll just call this one OMNIFIXO thingy. Oh, and you know, we could actually be using the same thing for both connectors and PCBs if this thing actually holds like a PCB, or not PCB, a connector inside of it. Yeah. Okay, okay. I got my iPad and then just sketch out what I'm kind of thinking. Okay, air server is up. Let's turn on air server. Oh, let me go get concepts up first. Well, that took a while to load. That's weird. Okay, let's stream to that and then turn on air server. Okay, cool, cool. Okay, so I guess let me just reference other one. So if that one 3D printed design that I found has something that probably looks like this, and then let's say that's like the spring. And then I guess this is like the base of it. And then there's probably like a magnet embedded in here. That does not look like an embed. So yeah, let's say there's like a magnet down here with probably 1 or 2 layer thick thingy just preventing it from popping out. And then we've got like a little slidey piston here that can move up and down. So if that's what this design is doing, and let me also actually look at just kind of how other people are implementing it. See, that's a remix of this model. Yeah, that's exactly how it's working. Here's another way that someone did it. I guess they did not enclose it actually here. They just, oh. They use one of those magnets that actually has like a little hole in it. I should get some of those. This one's actually a bit simpler, because it doesn't even enclose the whole entire thing, and it exposes the spring, which I'm not opposed to doing. Let's see, what else? I could actually do kind of a hybrid, actually, where I basically make the, I guess, just kind of single column one, but, what's up? Hi, Sparks Maker. Yeah, I've been kind of shopping around for different CAD programs a few months ago, because, let's see, I was using, like, back when they had SolidWorks education licenses, that were not tied to, like, universities and whatever, and, like, I think they're just giving them away like any organization, like Experimental Aviation Association and Titans of CNC had like their online course thing, which would get you like a SolidWorks education key. And the SolidWorks education version is like, it's just solid. Like no pun intended, but it just works well. There's no like always online bullshit or whatever. I think the only limitations are that like any files that you make with it say that it was made with education, and it adds like watermarks if you're trying to do stuff like for profit, which I don't care about if I'm doing hobby stuff with it, but like, I mean, it makes sense why they'd have those limitations for profit. I'm not complaining about that. I'm just stating what they are. But then like, SolidWorks Maker is just fucking terrible, because like, and I've tried it like, I tried it last year, I tried it like 3 years ago, and it has like this ancient website which is like the least navigatable for actually kind of like installing a launcher. And I think it does that kind of thing where it has like 3 layers of like, okay, you have to install the SolidWorks Maker experience client to install the SolidWorks Cloud installer, which will install the real installer so that you can launch SolidWorks. And it makes you re-log in like every few weeks, and if you haven't updated, then it locks you out. And I mean, Fusion does kind of the same thing, but not as crappy. But yeah, it just really sucks. And like they use like the worst web design from like the like 2010s or whatever, or like even before that, where like they try to get all cute with like hiding menus inside of like images and stuff, and you're like, oh, I didn't realize that was a fucking button because you haven't done that for 15 years. But yeah, it's terrible. I do not recommend it, and it's a mistake, and it does that thing where it leverages the worst possible cloud features without giving you any of the good cloud features. Now, if we want to talk about what a good cloud CAD thingy is, we can talk about Onshape. Because Onshape is 100% cloud, but the thing about it that's nice is that it does all the compute on cloud for you. It organizes it like SolidWorks Maker. The only reason that it ever needs cloud stuff is to enforce that you're logged in, and to enforce your license, and to enforce your updates, but it doesn't actually offload any of the compute for you. And then Onshape is like, you know what, we're gonna make everything cloud. We're gonna make this all run in a website or an app, so you can run it on your high-end gaming PC, you can run it on any Mac or any Linux computer. We don't give a fuck as long as it actually has a browser on it. You can run it from a goddamn Chromebook. You can run it on, well, probably not something from 1998, because I don't think it's gonna have the web standards for that, but you can run it on basically anything. And it uses the cloud stuff, but like in a way that you can actually take advantage of. Now, I didn't go with Onshape in the end because their like commercial license was too expensive, and I am starting to use like CAD programs for actual commercial stuff, and I don't want to get in trouble, which, like, let's be real, companies don't really care if you pirate stuff for like personal use, but once you're making money off of whatever you're doing, then they actually start like suing you and stuff. But yeah, and then I hate Autodesk. I just think they're a really sketchy company. There is probably a pun in there by accident. I did not intend that, but yeah, they're basically the Adobe of like the CAD world, I think. And I did not like how they were doing this thing of like, hey, we'll just have this like Fusion 360 personal thing that everyone can have for free, and it has all these features, and then just over time they start removing the features, so you have to pay for like the hobbyist, or not the hobbyist, the professional license, which is not cheap. It's like a few $100 a year. But frankly, it did end up still being the best deal compared to the other CAD programs that I was looking at, and it has a really good cam tool. And since I run stuff on like CNC mills, I didn't need that. So it just ended up being the best deal. I don't like Autodesk, which me saying that will probably kill any sponsorship opportunities, but whatever. But anyway, yeah. So I just don't trust them, but they ended up having the best price on the stuff, and I already knew how to use it. But yeah, it would be nice if FreeCAD could reach, I guess, levels of Blender where like they actually figured out how to make the interface nice enough and like make it more intuitive. Because like, I don't know, the thing that really turned me off about FreeCAD when I tried using it a few years ago was that like it's not only hard to use, but like if you complain about how hard it is to use, or say, hey, why do you do it in this way in like SolidWorks and in like Fusion and in Inventor and in Onshape, but you don't use it, you don't do it like this at all in FreeCAD. You have to do like 10 different steps to do it. And then if you complain about that, there's just like a bunch of people that'll like get mad at you for saying, no, the way that the other companies make you do it is bad and lazy and not the right way. You have to do it our way because it's the most deterministic. And we don't care about UX because our way is the correct way. The last time I messed with FreeCAD was, I think, a year and a half ago. And I think that was on the verge that they folded in, like, some really nice, like, I forgot the exact details, but it's just, like, a really big overhaul of the UI. And it did improve, and I think it's a step in the right direction. But at least as of, like, a year and a half ago, I still did not like the workflow of it. And, yeah. And, I have, like, a whole ton of other thoughts on the idea of Blender as a CAD program, which I respect Blender. I like what it's used for in, like, animation and games and, like, mesh modeling and, like, doing organic stuff. But it's not a parametric CAD program. You can throw all of the interface mods and stuff that you want on it to make it kind of like one, but it just isn't one. And I really need the features of, like, not approximating shapes with meshes and being able to, like, define stuff with equations parametrically, and, like, all the sketch things, like, this needs a tangent line, and this needs to be, like, just cutting these lines and stuff, and having all these constraints and whatever. But yeah, I feel like the only people that say with a straight face that Blender is a CAD program are people that have no fucking idea what they're doing with CAD and have never used a real CAD program. So they're just pulling shit out their ass about saying that Blender is a CAD program without even knowing what a CAD program is supposed to do and its purpose that makes it different from, like, animation and, like, stuff like that. But yeah, I ended up going on that rant anyway, but okay. So, let's see, what I was looking at. I was looking at more different spring-loaded, PCB holders. This is kind of the same deal going on here. Actually, it's basically the same thing. I guess if I just search, like, PCB magnetic, there will be a lot of these different variants. Yeah, this is basically the same thing going on here. Don't know if I trust that one to last very long, because I don't see any, like, any, like, metal hardware keeping together. Oh, this is a OMNIFIXO-like clamp. I mean, basically looks like the exact same thing, where we have, like, the ball joint to a magnet, and we have the parallel clips going on. I guess the only thing that I'm just kind of sussed out about using, like, 3D printed ones is that because it's a thermoplastic, and you're doing soldering stuff around it, these are inherently disposable because they'll start deforming with heat. But, yeah, I guess that you could probably, I don't know how strong resin-based prints are now, because last time I messed with resin, which was, like, 3 or 4 years ago, even the strongest resins were, like, weaker than, like, the cheapest PLAs. But something interesting about resin is that it doesn't melt, or at least the resins I've used haven't. They don't melt, they just sinter, but they don't deform with heat. And so it still kind of weakens, and you don't want to expose it to direct heat, but I feel like I trust that over that. Plus, well, I don't know, because if you're doing, like, if you're to get this, like, metal 3D printed, then you're actually probably spending more money than, like, just buying the OMNIFIXO to begin with. But, like, I guess if we look at these clamps anyway, it's not anything really crazy going on with this. It just looks like it's, like, stamp cut. You could probably just, like, laser cut the metal, like, from some cheap service like Send Cut Send. And then you just have, like, two 90-degree bends. And since it's metal, it's not gonna melt when you solder next to it. Okay, I guess just kind of looking at all these different, like, holding clamp things, they've basically got the exact same thing going on, though. So I think I have a good idea of that. But the difference for why I'm not just going to use one of these ones off like, printables or Thingiverse or whatever is, it needs to be something that fits the magnets I already have. And I also need it to be the exact height that I want it to be to work well with the OMNIFIXO, and also want to work around the what's it called? I also want to work around the springs that I have in stock ready. So yeah. Alright, so okay. That's right. I was on the iPad. So I think that I'm just gonna kind of reinvent the exact same thing that those other guys made. And I don't really think there's actually a need to, like, enclose a spring. I can't really think of any reason why I'd want to do that. Because I kind of like the exposed spring aesthetic. Oh, what are the machinist precision jacks? Because I've used a few different vices on, like, CNC mills and stuff, but I haven't heard of the precision jacks. Machinist precision jack. Oh, I have never seen that before. Okay, Is this used for... Yeah, it is used for, like, work holding. That's what I assumed when you said it was, for machinists. Okay, yeah, that's... I wonder if my Makerspace has this. I thought that I canceled my Makerspace membership, which I didn't want to do that because I love them, and, I'm actually steward there, but, like, having that lapse in employment, I didn't want to keep paying that membership while I wasn't working on expensive projects. So, yeah, I thought I canceled it, but apparently I didn't, because I just saw on, like, my statement that I'm still paying for it, so, I know what that had to do with anything, but, yeah, shit, what was it called? There's, like, you know, I can actually just look up, okay, assembly Makerspace Tormach. We have, I forgot what it's called, but there's like some specific vice that we use that, like, it uses screws to, like, you just, and kind of like the diagonal action thing going on to keep it in place. Okay, Tormach. Do we have the work holdings? Here it is. Okay, we're generally good about documentation, so, we probably have the name of whatever that is. It's not that. Wait. Okay, it's... Oh, Mod Vice, yeah! Yeah, this stuff is really cool. Yeah, this is what I usually use to, like, hold down stuff on the Tormach. Oh, wait, is this a mini, precision jack? Whatever this little guy is? Oh, y'all can't see that. Okay, let me go turn, there we go. Because it looks like a tiny version of, some of the, well, I don't Because of the point that, like, it just goes underneath whatever it needs to support, and you can just adjust the height of it. But this is not, it doesn't look like it's going underneath stuff. It looks like it's kind of keeping it in place, like, left to right. But, yeah, this is definitely my favorite work holding thing that we have at the makerspace. Bless me. But yeah, okay. So I guess going back to the iPad, so I was thinking that we have that one standard thing, and there's also just a screw that goes down the whole length of that. And then, and I guess I could also just kind of cut the, cut those magnetic bars that I have in half or something. I actually haven't tried that before. And that might require, like, 3D printing a little miter box for that, but... And, you know, I think I might as well do that, and just see how that works out. Okay. Let's make a custom miter box. Ooh, actually, I'll just... Okay. Measuring magnets with, like, metal... With, like... I completely forgot the word for it. Calipers. Measuring magnets with calipers is always kind of awkward because they want to stick to them. Okay, so that is 30 by 10 by 5. So let's go with... Actually, I think I want to do it vertically. It's actually a little bit less in all those dimensions, so I'm not even adding, like, any, what's it called, tolerance to that. Yeah, sure, we can go with 5. And then let's make that, like, another, actually, -10, it doesn't matter. We have lots of, this is a small thing. Fraction, two-sided. Let's actually just go with, like, -8, and then, I guess 8? Oh. Why is that 2 object? Okay, -8, and then let's go with maybe 12 or so. Oops. That did not do what I expected it to do. Okay. 15. 8. Yeah. Oh. Actually, let's just have that as, like, a single direction. Okay, one-sided. -8. And then up here, this one goes up, let's say 15, give it some extra space. And then... Let's see, I want to give it some, like, extra room to go down into. Let's make that, I guess, 2 millimeters. And then, if I want to cut it, like, in halves, or in quarters, or in thirds, we'll just have, like, a bunch of different options for that. So this will be whatever 40 divided by 3 is. And then this will be 10. And let's construction all of those. And then let's make some slots. So that's the quarter, that's the half, and that is the third. Is equal, and the blade width of my hacksaw is about 1 millimeter, so let's make that like 1.5. Oop. Okay. Doop. And then let's just add some nice fillets on all of those, just to help guide the blade in there. We can make them a bit big, and then I think, oh yeah, I was gonna add some like little holes that we can just push the magnet out of the slot with. I think maybe just at the halfway points of all of those probably makes sense. Okay. And what is the diameter of my silly thingies here? Let's go with the smallest part. No, let's just go with the normal one. What is... Oop, there's a magnet on that. Okay, that's 3 millimeters, so let's make that like 3.5. Oh. That... Okay, that one just wants to be weird. There to there. Make those ones even, and then... Okay, this is one thing I don't like about Fusion, is that it's really bad about picking out different regions within a sketch. Okay, cool. That works. And then let's 3D that. So yeah, we cut things in half, in quarters, and in thirds. Shit, I did not show that at all. Okay, this is what I was working on the whole time, like the past 5 minutes or so. I'll just go step by step on that. Okay, we have the base of it, and then we have the thing that actually holds the magnet in place. And then, we have slots for halfway cut, quarter cut, and third cut. Fillets. And then we have little holes in here to push it out of the thingy. Okay. Alright, so let's see. Let's just make this like super fucking thick. Strength, let's just go with like 6, 6, 6, because I just went to metal show so that thematically fits. Okay. And my bamboo was just printing TPU, so I need to get that out before I can actually start printing. Okay, 250. And where is the filament that I want to use? Have some clear. Okay, if this is going to be used for soldering stuff, I think I actually want to use ABS for this. So, where is my ABS? Okay, TPU, TPU. You are ABS. And almost out. PLA, TPU, TPU, PLA, PLA. I'm just gonna use TPA for the miter box, but I'm using ABS for the actual thingy. I kind of want to use my polycarbonate, but also it's not dry, so it's just going to print like crap. And I'm not going to wait for that. TPU. This other printer has my ABS, so I guess I need to, like, take it out. Okay. Let's heat you up to, like... Oh, right, that's right. I actually have, like, a macro on here just for removing filament. Okay, okay. So that one's going. Shit, the bamboo is unplugged because I slid it out too far. Oh no, it's because something fell on the cable and then the cable pulled out. Okay, okay. We're back. Oh wow, that reconnects really fast. Did that reconnect? I don't know if that actually did. It did not. Okay, I'm just gonna have to do this manual then. Okay, I got the ABS recovered from the other printer. I don't know if I want to use white ABS, but it's what I have on hand right now. Okay, so I have ABS loaded in the AMS. Do I have any other ABS colors ready to go? I guess not. Okay, I guess we'll just work with that. And if I really hate it, I can just change it out another time for V2. Okay, okay. Let's pull that existing TPU out, and then we have white ABS in there, and then we have purple ABS in this one. And we have clear PLA in that one, and might as well load some, like, some black PLA in that other one. Wherever it is. Oh, I do have some black ABS. Okay. Okay, black ABS actually goes in here then. Alright. Slide you back in place. Oh, I need to reconnect the tube. Okay, AMS is reconnected. Let's see. Cool, so if almost all of that is ABS, and I don't want to waste that PLA because it's clear, I'll just print this in ABS, I guess. Yeah, 30 minutes is fine. Okay. So let's go back to the iPad. And so what I was thinking that the second one would look like would be pretty similar, except we have that long magnet here. And then we have two columns of screws. And then we have our springs here. And then we have the bit that pushes against whatever we want to hold, but it'd be bridged here, and then here we'd have a little dip so that we can hold like connectors and stuff. And then there'd be like two attachment points here basically. So we'd have one of the, or we'd have two of these, and then we'd have one of these. That's what I was thinking this would be. And then with the second one here, we can actually hold like an XT30 or something in there. I'll probably size it so that maybe XT90 is the maximum it'll hold. Yeah, I think that's feasible. And then it can also hold like PCBs that are just by itself also. And I think that probably makes the most... Oh, you know, I think I know why maybe they have the entire cylinder... Well, no, never mind. That actually doesn't do it. I was thinking it'd help with like the stability of it, but I don't think that's actually an issue. Okay, so we have that miter box doing its thing. So let's design whatever this is, and let me go just put that in the corner for reference. I guess up here, yeah. Although, let me go refill my drink real quick. Okay, Dux, I'm back. My arms are not, and neither is my head. I wonder if there's a way to set the timeout to like 5 minutes or something. It seems like that as soon as you get out of range, it like just kills all the trackers like within 5 seconds or so. Okay, Alexa, turn workbench light on. I really need a separate button for that. Oh. Why did face cap stop? Okay. There we go. Face is back in action too. Okay. Yeah. So how do I want to do this? I think I'm just gonna maybe make 2 of the exacts. Well, I think I'm gonna make the first one actually, where it's like just a simple column version, and then when we have that down and like starting to print, then I'll just like kind of copy it over and modify the geometry so that it fits like the long wide boy version of this. But yeah. Yeah, I think that's sensible. And so I think I want to go with the half magnet size also for this also. Okay, so that's gonna be 10. And that is gonna be 20. Or no, I think I'm gonna design the magnet part last, actually. Oh. I just did something weird. Okay, so... I guess first... I have these numbers memorized. But this is gonna hold, like, the, This is gonna hold the, heat set insert for the, screw. And, you know, I might as well just get one of these in front of me for reference. Alright. This is what, 8 millimeters long? 6 and 5. 5-ish. So this part holds the, heat set insert. And then this part just helps stabilize, I guess, the screw. And if that's 8, let's maybe 7-ish, probably fine. Okay. So let's reserve, if the magnet's like 5 millimeters, let's say that we have like the bottom is gonna be like 1 millimeter at most, and 6, and then maybe we'll have like 4 at the top at most, so let's reserve 10 millimeters just for the magnet-based stuff. And then that means that the overall height that we're shooting for where the PCB should be held at is whatever that is, which is 45 millimeters, so actually a decent amount of room to play with. Okay. So I'm just gonna go right down that from here to here. We want that to be, what was that again? 45, right? Yeah, 45-ish. And here we're already at 15. This part, it's just gonna be kind of, I guess, a dummy bottom on that, just because I just want to be able to visualize it better. Let's have this be 10 and then -1. So this bit here that's floating, it's not actually anything, it's just kind of placeholder for the eye, I guess. And then what are the different springs that we have we can play with for this? We got at least 4 of them. That is a little too weak. That's a smaller one, but it's actually a bit stronger. When did all these got, like, mixed up? If we go with one of the bigger springs, or I guess bigger diameter springs, we can actually have some space to guide the, what's it called? I'm dropping these. We have some space to actually put more guidance around the, screw. But I think I want to go with this size. Which is, 3/8 by 3/4 of an inch. That's like, what, 16 millimeters by 8 millimeters-ish? But yeah, found 4 identical ones. And I'll take one of them back at my desk. Okay. Internal is about 8 millimeters exactly. And then when unloaded, we're at 17.5 millimeters. Yeah, I think it would actually probably be better to do something like that instead. So 4.5, and let's make this 7.5. And then let's maybe make it so that we can compress it up to 8 millimeters, I guess, for bottoms out. So that means that we have, I'm gonna go make a fake little springy spring thing. .5, let's make you 8. And, yeah, so that's 18 millimeters high. 18, let's make it 17.9. Offset it, 0.05. Yeah. You know, that could actually probably be a bit wider. Because the whole thing is actually more like 10 millimeters wide. Yeah, that looks kind of more visually accurate, I guess. Okay, so what are we looking at here? So we have 10 millimeters. And I think the goal was 45 millimeters from there to there. So, let me just make sure that is actually around like 10 millimeters. Yeah. So we can actually enclose it like kind of from the bottom, I guess. We should probably name these bodies spring placeholder. I'll call this one bottom placeholder. Call this one bottom half. Okay, so this thing here, I think I want to make the part that kind of slides over the screw threading pretty generous, and maybe also add some like some fillets so that I can glide a bit better. And I might actually be able to dig up like some partially threaded screws from another box, but I can't count on that. Well, let me actually go check that real quick if I do have any that are easily accessible. Because if so, then we solve the problem. Wait, no, I don't. Those are M5, not M4. Okay, no partially threaded screws. We're just gonna deal with the M4 ones and probably just add some features to help it glide over. Okay. So I have that. And we need to sanity check that outer diameter. Make it like 10.5. And this is something where offset you by 0.5. And then we want you to go to that object, but in 45mm offset. Why can't it do that? Or new body? Okay, let's just... Okay, so 36 to 9mm, I guess. And offset by, like, 0.05. So, 9mm. That way, and you actually wanted to project the outside of that also. Okay. Cool. And then it's gonna be that bit that we just kind of cover up on that shaft. So you will go -8. Actually it has to start from here. And then have we go to object here and then offset that by 8. Yeah. So if this is a spring, which, okay, this is definitely not the right way to make a spring, but like, it'll get the visual across though. Actually, no, that's stupid. I'm not gonna do that. I know there's like a helix tool thing, but I'm kind of too lazy to do that. Well, no, shit, I'll do it anyway. Okay. We're gonna make the spring properly, I guess. Create sketch. Project you the entire damn thing. Okay, and then we'll just make you like, 1mm. I guess 0.8mm. Tangent and tangent. Okay, so I think that if you go to that coil thingy, and then hide that. Okay. What is going on? Why is it... Do I have to open that and then go to the coil? Oh. Okay, I did that wrong. Alright, coil. diameter is 9. And then 1. Then that looks like 5-ish revolutions to me. And negative 18. Negative 17.5. Close enough. And it should be a new body. Okay, there. Now we can just... I won't worry about that. Okay, so... yeah, we have a spring here. We're gonna have the, heat set inserted in there. And then we'll have a, screw just go all the way up here. Might have to custom cut those screws. And then need a thingy that actually stops it up here. So you'll be 4.2. And then project that around. Then I'll just offset you like 0.01. And then, no, probably 8 is good, I guess, there. And then we'll clear some room for the screw head. So you'll be 8. Negative 4. And then, let me just make sure I actually have... yeah, maybe negative 3 is actually probably better. Oh no, maybe we should make this one up 9. And then I need 40mm M4 screws. So wherever you are, there you are. Make sure I have like 4 of them, so... okay, how long are you? You're 40, perfect. And I actually kind of like not having to hide the entire head in there, plus I have so many of these that I think I'd rather use these. So instead of designing it around the socket head ones, let's design it around these button heads. Oh! JJ, sorry! I accidentally stepped on my cat. Oh, he's getting head pats though. He is enjoying those head pats. Okay. So we don't actually need that to go all the way like that. So what's the distance from you to you? That's 40, that's perfect. Okay. Now, aesthetically, what do I want to do about this? Because it's kind of plain right now. I think I want to add some knurling features around this, because that's going to be going up and down. And knurling is cool. Yeah. I also could try to make it look like it fits the OMNIFIXO ecosystem. And take some cues from like the little yellow bases on that. I think I'll do that actually. Okay, so I'm gonna go add some fillets. That are just kind of unified there. And then... let's see, I think from here, or at least from one of these sketch planes. Boop. Let me add the stuff here. Okay. Set those to construction. Then add some slots. calipers. Calipers, where'd you go? Okay, so I was talking about basing it off of this. And, oh, you know, that's actually not a fillet, that's a little chamfer, so let's do chamfer instead. But yeah, that is about 1.7. Actually, what is the width of this anyway? Because, you know, it might be more aesthetically pleasing if it matches that. What? Oh, we are already at the correct width here. And it looks like that when I eyeballed it, I was actually pretty close. So that's like 1.5. And then let's cut that out. Offset by 7, I guess? Yeah. I'm actually gonna also add that feature down into there. Okay, slot feature from here to here. Make that equal. And then maybe you can be like, I don't know, 2. Oh, and it should probably cut all of those objects. Yeah. And then how many of those do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So where is the revolve pattern? Okay, access is this, and objects features will be this. And we have 12 of them. Okay, yeah. You know, it is actually kind of a bit of... I mean, honestly, at like this... At this scale, you can't actually tell the difference between like a chamfer and a fillet when it's printed, so... Okay. So we have that, and that means the bottom just needs to hold magnet. Yeah. And let me just kind of get a cross section of this just to feel sane. I guess actually first I want to just kind of add the screw also. Okay, so what is the diameter of the screw head? It's 7.5 divided by 2. And then you are going to be 3.999 divided by 2. And you are going to be 2.5 millimeters. And 40.01. That should not intersect. Will it? Ooh, it might. Let's make it 40.1. Yeah. Okay, revolve. That's the axis. Yeah, this is gonna be CAD screw. This one's gonna be, yes, static top. It's gonna be spring. It's gonna be slidey middle. I don't think that's how slidey is spelled. If slidey is even a real word. And I'm not gonna bother to model the heat set insert, but that's down there. Okay. Should probably save this. We're gonna have that OMNIFIXO project. OMNIFIXO single stand thingy. Okay, cool. So where is that ultra thin thingy? Let's actually make this like -0.01. Just so it's like super thin. Okay. So I think the way that I want to do this is just like we're gonna like kind of slide in the magnet and then just kind of like force fit it in. Maybe it has like a little pocket that it sits in, and then we can just like kind of seal it in with some like plastic melting. Because it's not gonna be like anything's gonna try to force it out, I guess. So, yeah. I guess I could probably maybe like just save a variant of this. I don't know. Okay. So let's say that we're going with the do I want a quarter of the mag? Well, how fast is this thing from finishing? Maybe we do only want like a quarter of the magnet. We can experiment with that at first. Okay, so let's offset this by like, I don't know, maybe 3. And this entire thing. Touches that. Let's actually make it go even further. There we go. And then here we can just... let's project that down here. And then create a bit of space for that magnet to fit in. And this time, because we're like kind of force fitting it in, let's force fit the right... yeah. Force fit or snug fit or something like that. We actually do want to get the actual magnet dimensions. Wherever the magnet sample is, I don't know where it is. We have a bunch of magnets though, so. But, I mean, this thing's gonna be pretty easy to adjust, so I'm not too worried because I'm just gonna wait for that magnet miter box thing to finish printing, and then we can actually just cut some magnets up and see how that goes. Plus, I have like a bunch of like cracked magnets that would actually be really good to use for this. But I also don't know how these magnets respond to being cut by like what's it called, by hacksaw. So could end up not liking that. I just broke this entire case. Oh well. Not sure if I cared about it that much anyway. Okay, so here's magnet. The exact size of this is 9.8 millimeters by 4.8 millimeters by 39 millimeters. Length is not as important for this, though. Care more about the, that. So let's just add like 0.1 millimeters for tolerance on that. 4.9 on the width. We have 9.8. Let's make that 9.9. And on the bottom, I'm thinking this should just be like, if I use 0.3 millimeter layer heights, I think it was like 0.6. That could work. And then -13 maybe? Yeah, I think that would work for what is it called, for quarter magnet. And then just a bit of feature here to let it, I guess, welcome it in a bit better. And then project that. Another 3.5 millimeter hole so that we can push out the magnet easily if we want to redo this or something. Okay. So yeah, that looks like it should be able to fit that in. Does look a little silly though, I think, for some reason. That actually does not look bad. I could work with that. So it's a little awkward because it's holding a I guess it's kind of awkward because it's like holding a square magnet inside of like this thing. But I also don't think it's gonna make creating like the kind of bridge thing that I was talking about bad actually. And we are done printing. Can I knock this off of the print bed right now, even though it's like hot? I forgot if oh my god, that looks terrible. Oh, what the fuck was... That's nasty. I should have paid attention to it while I was printing. And it's like slightly pinkish. That's weird. And I don't know why the bottom is black. I'm kind of concerned. Okay, so the print bed did not get ripped off though. I still don't know why the bottom of that's black. I don't really trust that for, now this is junk. Rip. Ugh. Okay, so I think I'm actually just gonna load some PLA and reprint that, but like, faster, I guess. Okay, run macro. Change filament. But what I was thinking is that, let's save a copy of this double stand. And let's also open the single stand version of it. Why the fuck did I call things that? Anyway, OMNIFIXO thingy, single stand. Okay, now we have both those projects open. Can replace you with a black PLA. Okay. That is unloaded. And now we can load black PLA in there. Wait, that is not loaded yet. There we go. Okay. How long will that take? I'm surprised it actually takes that long, because this feels like a part that could be done really quickly unless literally everything is treated as a wall, but yeah, I want to save some time on this. Okay. Yeah, let's go with that. Okay, the double stand thing though. What I think we could actually do here, I'm gonna go undo those fillets. How long are you? Well, actually, that doesn't even matter. Well, maybe it does. Because that's gonna be 13 deep. Which means I could transpose this entire thing. Possibly. Whoa. What? Why is it doing it from that? Okay, move copy, green copy. There we go, that's what I wanted to do. Is 30 millimeters the right distance for that? Because that should be 46. Okay, yeah, that is the correct one. So in that case, we would just take this. And then we would just dupe you out. Take that. This would go in here. And then we just shove an entire magnet up that ass. And then let's go restore those funny features here. Well, actually, no, let's do it on here first. And that can actually be something like that. Maybe even 7.5? Ooh, spicy. So what's the distance from there to here. Oh, you know, I like that better. We can actually contain a square inside of that. Okay, that's a lot more aesthetically pleasing. I'm down for that. What was that, 7.5? And then I guess here the little slots disappeared for that, so... Okay, yeah, I like that better, actually. And then... just add a little 0.5 chamfer to that. Maybe 0.6? 0.75? 0.7. Close enough. Okay, I'm down for that. That looks better, I think. Yeah. Is this thing printing? It's preheating. Okay. So, yeah, I guess kind of on a similar vein here. Let's make that... Wow, it's not actually even a 7.5. What should that be? Is that 16? Okay, so let's actually make that 8. And I have a feeling that down here, this is not a true circle, but like a squircle. Okay, so let's make you 8 also. And then I think that just actually straight up erases that, so yeah, you can just have that. Chamfer is not happy. So if that was like 0.5. There we go. There we go. So now that's a true circular thing. Okay. Cool. This is going to be a bit of a weird thing to print, though. I mean... what we could do is, instead of that being like that, you could just take this and offset it. Plus, these magnets have like little, very slight corners going on here, so we can make that like 0.5, I guess. I didn't want to split the files too early because that means that we're gonna have to like perform double maintenance on both of these. But what I think we could do here actually is take that and then offset this by like 1 or 2 even. 2? Let's do 1 actually. And then what we do here is just cut out this bottom. Because there's no reason that this has to maintain like 100% contact on the steel, whatever. iPad battery is getting low. Let's start charging that. Okay, so iPad is charging. And let's make this like a fillet of 1, I guess. Well, let's also add a little fillet on there. Okay, and then that lets us put like some little tree supports here that we can just remove pretty easily, and magnet's not flexible, so it's not like it's gonna slide out or anything. I think that's reasonable. And then we can print, let's just do an audit of all the printable things. Screw is not printable, the spring is not printable. So we have, maybe I'll prefix these with things that actually need to be printed. P, or PR, maybe. Okay, so little audit of what is printable. PR bottom half. This looks printable to me. We'll just have tree supports going up through there. Maybe not even tree supports, maybe just normal supports. That should be able to snap off very easily. And then, yeah, that looks good to me. Their diameter is 4.5. Okay. Slidey middle, that is very easily printable as long as we do it like this way, and then we don't even need support for that. Static top, also extremely easy to print. Cool. Cool. Alright, double stand. So let's do the same thing that we did here. Project that. Offset that by, was it 1? Yeah, 1 looks about right to me. Extendy those line things. Extended and extended. What the fuck is going on there? Okay. Tangent symbol, we're good here. Alright, so let's take you and extrude it out. And then take that, and just fill these 1 millimeter. And then, yeah, that also looks like it can be tree supported with no problem. And let's add the 0.5 millimeter chamfer here. Cool. So yeah, we can put a little magnet in there. We can push it out if we need to. Magnet's not gonna fly out of there. And worst case, we can use some epoxy. I've not mixed epoxy in a while now I think about it. Is it weird if I say I like the smell of epoxy? I just do. Actually, I think that little bit here is really ugly. I don't want to do that. Although, fillet might actually look okay here, though. Let's see how that looks. Nah, that's fucking ugly. Let's not do that. Okay. So yeah, we have the double version of it, but there's no point in making double version unless we actually bridge those bits together. So, slidey, whatever. Okay, so bottom half is a unified piece. That is intentional. And let's add the, prefix for, printable. It's funny that prefix also starts with a PR. Okay, so, hide the screw, hide that screw, hide that spring, hide that spring. And then, I guess, okay, cool. We already have the, visual of how I was intending to, bridge them together. So, I think the easy thing here is let's just bridge static top first. What time is it in Germany? Alexa, what time is it in Germany? Holy shit. Okay, I wasn't going to call you out if you're, like, going to bed at, like, midnight or, like, 11, but, yeah, wow, 4 a.m. Okay, yeah. Yeah, you should go get that sleep. I mean, not that you shouldn't get sleep in any case, but, yeah, I'd say that 4 a.m. is a reasonable time to get some sleep. Yeah, thanks for tuning in. Go get that sleep. Let's see. Okay, I think here I'll just extend that. I mean, I'm not exactly one to talk because my sleep schedule is also atrocious. But, yeah, saying that you slept for a few hours earlier, it's like, maybe you should get a bit more sleep. But, I mean, my sleep schedule is really terrible, so I'm not one to talk about that. Yeah, it sounds like you got something important to do, so, yeah, you should probably take care of that. Thanks for tuning in, and helping moderate my chat. Always appreciate it. But yeah, go get that sleep. Bye-bye. Okay, I think 3mm is probably good there. And let's see, no, that doesn't even want to process. It's okay, it doesn't want to. Okay, so static top is a single piece in this context. And then let's take slidey middle 1 and slidey middle 2. How do I want to do this? Okay, what are the XT90 connector dimensions? Will it even fit in between that? Okay, XT90. I don't even know if I have any XT90s on hand. I used to, but I don't know if I still do. But XT90 is the biggest connector that I deal with. I might just straight up have some right here. Not in that box. It is in this box, though. And yeah, that is definitely not XT30. That is XT90 as fuck. It even says XT90. Okay, okay. So... let's see. Thickness of this is 10. Yeah, that's definitely a good reason that we wanted to make something that has a little divot for that. And the width, which is more important here, is 21mm. So, what is the rough distance between here and here? 15. Okay. Means we're gonna need to carve out a bit more than I thought we would. That's okay, that's okay. Project you, project you. Something's unhappy. Okay, it's happy again. What was the method I did on the other thing? Yeah, I just made a slot. Okay. It's weird that it's cut a slot, because sometimes it's not, like, solid, so... Yeah, let's do it the same way where I extended that. And I extended that. And that, and that. And then let's make this one even thicker. Let's make it like -10. Cool. And then... I don't want to do this. Okay, so the width of this, I guess the length of this is 20. Thinking that we could actually carve out a bit that is not all the way through, so that we can use one side for, like, if we just want the entire side to be, like, grabbed. And then we can use the other side for, like, if we don't want the entire side to be grabbed. I don't know if that made any sense, but it makes sense to me. So yeah, let me just... It's actually the wrong reference point. Let's remake that. Okay. Let's add a center line here. I don't know what the difference between center line and construction line is other than visuals in Fusion 360, but it might be a thing. Let's make this maybe 24. Oh no, 24 is a little too close for comfort. Let's make that 22. And then it's kind of vibes based, but whatever. How deep does this need to be grabbed for me to feel it's confident? I want to say probably maybe like 12 millimeters, I think, is probably a good estimate. So yeah, I think if we cut out this chunk here, this chunk here, then that should probably be a good basis for grabbing stuff. Bless me. And let's see. Do I even have any like XC30s in here? Oh, I have XC60s. Because we need it to be indented by at least 2 to fit the XT90s. But I don't want to be indented so far that we can't actually grip anything smaller than that. I mean, I also could just straight up look up the XT whatever dimensions. Okay, we're at 5 for that. I have a battery here. Perfect. And you are 3.8. So maybe -2 is actually probably the best amount to cut that by. And note, it is only on one end. That is intentional because I wanted to have one where like the entire broadside makes it in. But yeah, and then I want to chain for this maybe just 2 or so. And the distance from you to you is 18. Is that okay? Only if the distance from you to you is... Ooh, that is barely... No. Okay, yeah. I should probably make that like 60 degrees. Alright, that's 30. And then... Yeah, let's just make this 24. Okay, so sliding middle, static top. Yeah, this is gonna be the side where the entire thing you can use the clamp, and then this is gonna be a side where you have a little indent for even bigger things. Yeah. And then you just slide the magnet into that little bit. And then we've got the 2 screws here, and then we got the 2 springs here. And that definitely looks like something that could fit a PCB on that side and a PCB or connector on this side. And then we also have something here that can hold corners of PCB or a really small, tiny PCB in there. Cool. Okay, I'm gonna go pee real quick again. Okay, Dex, I'm back. Let's see. How far are we on this print? We're 10 minutes away. Thought that we'd be done faster. I think it probably helps visualize this a bit easier if I actually color this stuff and maybe add a little top to that screw. So I'll do that. Okay. So, what is that 2.5? Can you just confirm that's 2.5? 2.5. There, through. Okay, yeah. That's 2.5 the corner or the thingy? Yeah. It's the distance from the flat to the flat. I'm just gonna estimate -2. I'm just gonna save this as magnet miter. And then here, I wonder if it's safe to do this. Polygon. -2. Okay, I guess that was safe. Alright, so I think just to make things easier to look at, I'm just gonna color all of these. And wherever we got like metallic black. I mean, it's more of a fake black, not fake, flat black. Probably go with powder coat. That if it doesn't apply like some wacky texture, I guess. It doesn't even want to apply to begin with. That's annoying. Why is that not applying? Oh, do we need to download it first? Yeah. Ugh. It applied some, like, nasty orange peel. Okay, screw it. I'm just gonna put metallic black on there. And let's also apply, I don't know, some kind of shiny metal. Chrome. Let's go with chrome. Everyone loves chrome. It's funny. Closing my door. Okay. Let's do the same thing here. Chrome on that spring, and... is it paint that we had metallic? Yeah. Okay. So, I guess what colorway do I want to go with this, though? I mean, honestly, I kind of just want to, maybe just for reference, go with, like, the standard, OMNIFIXO colors. Create your online appearance collection by adding materials in this design. Okay. I'm gonna be lazy. I'm just gonna use that as the color for it because it's pretty close to like the OMNIFIXO orange. Yeah. I'm just gonna use that. I feel like I should probably model the magnet in there if everything else is modeled in there. I mean, this is just materials, right? This isn't like... Or this is just appearance material, not like we're actually simulating the stuff. Okay, yeah, I think it is actually probably a good idea to put the magnet sections in there just for a sanity check. Yeah, let's do that. Okay, so from there to there is going to be a reasonable distance, I guess. Can you add fillets to this, like, preemptively before we resize it? Where's the fillet thing? There we go. Let's make it... Let's actually measure it. Feels like something that we shouldn't guess on. I think 0.5 is probably the most... I think that's a reasonable conservative estimate for that. Or, you know, I don't think that actually matters right now. I think we can do that after we do this, and just, as long as it's a different body. $39, actually. Which is even better for our case. And then... what was that? Was that 4.8 millimeters thick? Oh, I just pulled that from out of nowhere. Yeah, 4.8. Okay, so we can hide that. We can hide PR bottom half. And then here we can just go nuts with all those things. Yeah. That looks like a magnetic bar. Yeah, that looks reasonable to me, I think. And then let's do the same thing here. Let's see, that'll be 10 by 10. This is probably gonna be like 9.8 by 10. And then if we hide PR bottom half, then we've got... I do not want the hole inside of there. There we go. Okay. I'm a little concerned that it automatically added those. Oop. Okay, okay. Let's see. We're at just 0.5, I guess. Appearances, chrome, let's slap that on. Yeah. Okay. Well, that looks good to me. Although, I don't like that spring placeholder, and I think I'm gonna try to delete that if it's not going to get mad at me for that. Where's spring placeholder? Where's the delete, body thing? That sounds like it gets mad at stuff, so I'm not gonna do that. Okay. Let's see, and I did want to actually just make the spring ends actually revolve around so it looks kind of like a real spring end, I guess. Oh, thingy is done. And this is like just cosmetic, so I should not care about it as much. Cool. Okay, let's see if we can actually cut a magnet. Or if that is asking for trouble. And let's also make sure that the print actually worked this time. That is some. Let me dig that other crap out of the trash. I still don't know why it was pinkish, but it was. But okay, yeah, that is so much better. I'm actually really surprised to see this come off of a bamboo, but whatever. Okay, so let's see what happens when we try to cut magnet with a hacksaw. Okay, so where is our magnet? I don't want to say victim, because that sounds really mean. Where's our test subject? How fucked up is my nail polish getting? Whatever, we got a different one. Okay. So, that fits. That is the first good sign. And we can just pop that in there, and just make sure that the pop it out thing works. Tolerances may have been too tight, but we can do it with a different driver easily, so that's good. And this is never meant to be used standalone. This is meant to be put inside of a vise. So we are doing that. By we, I mean I, because I'm the one that's doing this. Okay. So, is this thing on? It is. So that looks snug to me. Let's do some half and quarter cuts and see how that goes. Oh, that is sparking. That is cool. Y'all see those sparks? I did not know I could actually turn the camera like that, but I'm not complaining about that. Oh, those sparks are so cool. I love sparks. But am I actually making any breakthroughs here? It's actually taking quite a bit to cut through. I thought it'd be easier to cut through, but I guess not. It's kind of stuck. Oh. Well, that snapped in half. The weird thing about magnets is that, like, once they snap, they don't want to, like, actually go back together, either. I mean, I have a bajillion of these. We'll just keep trying until it actually works. But yeah, this was actually kind of really weird. I might have to switch to like a carbide blade. How much impact are we making? We're making like almost no impact on that. Okay, carbide blade. Do you even fit in this shit? I mean, you're carbide, so if you don't, you're gonna make yourself fit. With carbide. And maybe I'll tilt this the normal way. Maybe I should not have a LiPo battery out around around sharp blades. Seems like a reasonable idea to me. Okay. Carbide blade, let's fucking go. But I also can't go too fast, because I think heat demagnetizes magnets. What the fuck? Everything's falling off. Okay, anyway. Something smells really bad. Okay, I guess that's the way to cut a magnet, though. It's not that hot, so I don't think I broke it. Like, in terms of the magnetism. Okay. Well, that looks like it's a magnet that has been cut. So I'll take it. Well, I guess that worked, but nothing we've designed for is like for a half magnet. for like a quarter magnet, so... But because we can't snap these things back in place together, because, like, cut apart magnets don't want to touch each other. I guess we can just put one back in at a time. Yeah, let's just try that, maybe, I guess. And then we can put, like, oh yeah, we can just put, like, a little tiny divider or something in there. Yeah. Something like this in there. And then we can cut that in half. Yeah, I'm so smart. The fact that my cat is still in here despite all these, like, screeching sounds is crazy. Something got destroyed. That was weird. I'm also smelling melted PLA, which has a very distinct, like, kind of like a, what's it called, almost like a candy smell. If you ever smelled, like, what, what's it called, candy corn? Not candy corn. Cotton candy maker. Kind of that kind of smell. But that shape is stupid. I'm gonna cool that off rapidly. I don't know about that. Looks kind of dumb to me. But we're still kind of strong on that, front, and then the other chunk of that magnet just got obliterated during this cutting process. And the, what's it called? Miter box is not looking so hot either. I think I went too fast and now it's like, just, it's, I mean, not just melted itself, but it's just not happy looking. Well, either way, we are done printing that thing, so let's just get some print started. Probably for the single stand bit, and we can do that all in one piece. Okay. So let's 3D print you. And then slide you middle. Let's export you to 3MF. I mean, honestly, let's just export all of them to 3MF the normal way. Let's call this one top. Easy. And let's call this one bottom half. did you save to anyway? Documents. Okay. Date modified. Okay, so it's all stacked on each other, and that's good. This one should probably be that way, and this one also looks good, and I think that one individually needs support. Where's the thing that lets us select just individual? There it is. This bottom half needs support. And let's just make it snug, I guess. Wow, this actually is taking shorter than the miter box to print. I mean, I don't think we have any tree supports for this. I'm gonna just do normal supports on snug mode. And just rip it out however we need to. Oh wait, this is definitely something that we want to be like really, really strong. Yeah, I think that's reasonable. Or wait. All of these should be that strong. Yeah. One thing I like to do when we have like little delicate prints like these is actually spread them pretty far. Come on, stop spinning, start moving. Okay. Actually, I like to spin these out pretty far across the print bed so that there's a bit more time for each layer to cool down, or else you get like that weird melty shit that the ABS stuff was doing. Although, speaking of which, let's actually use some ABS. How much ABS do I have left? Can I do this all in purple? I have like barely any purple ABS left. Let's do it in black. Or no, let's do the top and the bottom in black and the middle in purple. Yeah! Okay, middle is in purple. Your middle. What? Oh, wait, let's do one at a time print, actually. Wherever that setting is. There we go, now we don't have that stupid purge block. We got 25 minutes total, although we don't benefit off of that thing that I was just talking about. Ugh. Wait, but this entire thing is only like 7 grams of filament? Okay, fuck that. Let's just make it all purple. Or not. You know what, let's just... Oh, you know, a way that we could actually... No, wait. Let's just do this on multiple plates. And let's do 2 at a time while I play some Legends. Should I play League of Legends? Oh, hi! I am making, let me go find some reference pictures. Okay, so I have, an OMNIFIXO, helping hand system. I really, really like it for, like, soldering projects and stuff. But there is one, I guess, gap in functionality that I believe it has. Where did I put that other magnet? There it is. It has a gap in functionality where, it takes, like, 3 of these to, like, properly, stably hold, like, a single PCB, because if it's holding this, like, by a single one, then it's kind of easy to move around. If we hold it by 2, no matter what orientation we're at, then it's going to move along this axis, like that. So it takes 3 entire, grips to actually hold that in place pretty well, which leaves you with only 1 if you buy the standard OMNIFIXO kit for a wire. So, I want to make something that can hold an entire PCB in just a single, jaw thingy. And so I've based my design off of, quite a few different things, like these commercial products here, where some of them, they're only fixed height, and other ones, they have, like, little adjustable spring clampy things. And there's some additional, not those ones. Yeah, there's some 3D printable ones that some other people have made, which I am basing my design off of. But yeah. And so I am basically doing that, but in a way that fits the OMNIFIXO's exact heights and stuff. And a couple different variants for one that, like, is kind of more meant to hold controllers and, like, not controllers, connectors and, like, a single long thingy. And another one that is meant to just be the normal corner ones that all the other ones have came with. So yeah, that's what I'm working on. Okay, we need another bed there. Okay, so what does that one look like? Does that still have the, supports? It does. I mean, honestly, just for... Okay, so if all this is, like, only, like, what? 6 rams of filament? I think I'm just gonna do all this in PLA, just so that we can get that nice rapid prototyping goodness going on. And that faster print time. Because really it's just more important that we have a good test fit going. Yeah, I think that's reasonable. Because I can just print, like, the rest of the copies of these offline. Okay, let's slice that. I could have sworn this had, like, snug support. It did not. It had grid. Yes, that is snug support that I was looking for. Okay, enough overthinking this, because I'm pretty sure we spent, like, 5 minutes trying to optimize this print for speed. Let's just print this damn thing. Do I have League of Legends on here? Because, like, well, can I do anything else in the meantime? I'm only trying to play League of Legends to pass the time while I wait for this to print. I guess I could take this stuff... Oh, right, there is that spring thingy that I was talking about. Just so that I can make this, like, more accurate looking. Okay. Yeah, might as well do that. Because I know that people hate League of Legends even though I love it. It's very rude, but such is life. Okay, revolve. Profiles are gonna be those. In access. Well, that's... Oh, I didn't want to cut that out, though. I wanted to join those. Now this looks like an actual spring. Cool. We're just gonna do the exact same thing with the other springs. I guess that one first. Alright, project you. And project you. And revolve you. Yeah, we can just use the screws as a reference. Well, that's pretty easy. Okay. Project and project. Revolve. And revolve that. Axis. Join. There we go. Okay, so how are we doing on the 3 print? 15 minutes. League of Legends Swift play game is about 20-ish minutes. This thing is stupid. How do I just... Can I just... Is that gonna get mad if I delete it? It will. Let's just not worry about that. I can live with it. I don't think I have any yellow or gold filament. But if I did, that would be nice for approximating the OMNIFIXO look, I guess. But yeah. Can at least see what it looks like with the actual spring in place, though. But yeah, this slidey thing should slidey slide so that we can actually, like, get a grip on whatever get a grip on whatever PCB or connector we are holding. Still cleaning the nozzle tip. Now, let's try to cut more magnets in the meantime. That was the thing that was kind of being weird right now. So, let's try to cut more magnets up. Fuck up their day. Okay. So... this magnet is in place. I might need to do like some cycles of am I almost out of what's it called? Not compressible air, that sounds stupid. Compressed air. Duh. I might need to order some after the stream. But yeah, okay, let's also open up my trash can so I can throw away these like stupid fucked up magnet bits that I messed up. Okay, so that's 1/3, that's half, that's quarter. Let's go with quarter. And let's throw you away too. I mean, if we're just waiting for 3D prints to finish, there's not really a need to like rush the process. Although, you know, it might... I wonder if it would help to actually put, like, some tap magic on that shit. Where's my tap magic? Tap magic, where the fuck are you? Tap magic. Whee! Loop that shit. That could help it stay nice and chill. And let me see if I should order some more compressed air. Compressed air. What is the price on Amazon right now? Why the hell is it so expensive? Okay, let's not right now. Let's get back to face tracking. My face is back online, right? It's not. Now it is. Okay, cool. I guess this is also containing all the, like, metal dust. How far have we cut? Kind of like maybe a quarter in. Let's cool it down. Okay. I mean, I guess as pretty as sparks are, that also means heat is coming off, maybe? You know, I also have a Dremel. Maybe I should use that after this. Alright, how far are we? Say we're a little less than halfway through. Print has 13 minutes. Okay. How far are we now? More than halfway through. Okay, I think we have cut all the way through now. Without actually cracking the magnet into like a bajillion pieces. Woohoo! We sliced it properly this time. Although that feels like a lot less than a quarter of magnet. Maybe a third is the way to go with this. But that's a lot cleaner than the other attempts, at least. I'll take it. Okay, let's keep that around up there or so. and then this little fragment of a magnet. Just gonna keep it around there, and then we can just kind of like wedge it in with some bullshit, I guess. But maybe a third of the magnet's the way to go. Or maybe, I guess what I'm thinking is that in trying to cut a magnet in thirds, we practically end up with it actually in a quarter of it. Because we really want the quarter, to be honest. Something is shattering, I think. That's not a good sign. But we will continue. That looks better. I like that more. How do we clean all the dust off of this shit, though? Let's see. Okay. Can we just use, like, a bunch of rounds of paper towels over this? Just, like, keep pinching off dust until it comes off? Doesn't matter? I don't think it really matters, per se. Oh, I wonder if tape would work. Let's try tape. Let's try... I barely have any packing tape, and I need to use that for real reasons. Kind of a waste. So let's... I don't care if this is high-end Scotch electrical tape. We're gonna use it. What if we, like, just goon this in electrical tape? Oh, wait, I should use the goon gun. No, the goon gun's hot, so it might actually ruin it, because heat ruins magnets. But let's see what happens if we just, like, take this entire strip of, like, electrical tape and just, like, keep moving this along with, like, little tiny bits of the magnet dust. There we go. That'll keep it nice and taut. Will this work? So you just, like, roll it across Katamari style. Does it even matter? Or am I just being pedantic? I think that's clean enough. Okay, let's keep that somewhere for, like, safe storage. Say that like it's a enriched uranium or some shit. I'll just put it down on that little steel surface here. Let's go with a third. I think a third is a comfy value for this purpose. But let's also clear this shit out. And we could even vacuum it out. Okay, where's another broken-ass magnet that we can... Just wait for this. Let me go with this one. Something is clearly building up in here that is nasty. Where the fuck did I put that magnet? Where's that magnet? drinkies. Okay, I'm back. My trackers are not back though. Let's turn them back on. Doop, doop, doop. Arms are back on. Feet are turning back on. And head. There we go, we're back. Okay, go. What was I doing? I was cutting more magnets. At least I think I was. Well, we have this funny magnet remnant here. Let's just shove that along there. And find, like, some random crap. Shove in here to enforce the thickness of it, or some shit like that. Okay. No, that's probably enough. Let's pour some tap magic in there. And let's freeze it. Freeze ray. how, like, flash freezing something sounds like frying. Okay. How much time do you have on the print? We have 2 minutes. And I low-key don't even know where I put that other magnet that I just cut. Where did I put that other magnet? I put it down here. Okay, okay. We're good, we're good. We're safe. Let's freeze this a bit more. Okay, how far are we? We're like halfway through. Magnets are way harder to cut than I expected them to be. It sounds like the print just finished. And I think we're out of freeze water. Yeah, print's done. Just fucking... I hate cutting shit, man. Okay, we're done. You know, that's actually almost like... That is almost 2 halves of what we want. Okay. That's nice and cold, though. It might be worth looking up what temperature magnets demagnetize at. Or at least the standard neodymium ones. Okay. Because what I'm thinking is that we could just use hot glue and just coat the magnet in it and then just, like, take it out without any fussy fuss. Yeah, let's look that up. That's probably a good thing to look up. Okay, let me confirm. Okay, so I'm looking at Amazon on my phone. Let me just confirm that these are neodymium magnets. Is it neodymium? Neodymium. That's the word. Neodymium demagnetization temp. Oh. Wait, what? I trust K&J Magnetics more than the the AI bullshit, whatever, thing. I don't know how to read these curves. Oh, high temp magnets. Okay, so this one says 80. AI thinks is 80. This one says 80. Oh wait, but that's not demagnetization temp. Okay, hot glue gun temp. Okay, hot glue gun is too hot for that. Okay, let's not worry about that then. And let's actually assemble this shit just to make sure that everything fits before I do it out of like it's called ABS. And you know, actually, let me go get the other one started. Print. Let's see. Slidey middle and static top also need to be PRs. So I'll get these started printing. And then I'll start to get that one test fit of the things that we just finished printing out. Ah, shit. Yeah, I did it in the wrong thing. Yeah, I did it in the wrong thing. Okay, so bottom half. Export you to 3MF. Slidey middle. Export you to 3MF. Slidey middle. Holy shit, how did that explode? That's crazy. Although, I've only tried welding a couple times. Kind of scares me. It's a little... Okay, honestly, I thought that, like, welding would be similar to, like, what's it called, soldering. But it's way more scary than that. But although, at the same time, I was doing... What's the harder one? Is TIG welding the harder one that you can do for, like, titanium? Either way, I decided to learn, welding on hard mode with, I think, TIG, and it was hard mode. Is MIG the one that's like a metal hot glue gun, basically? Okay, I've got these ones. Let's put the double stand slidey middle and the double stand bottom half. This one still benefits from being printed upside down, but both of these do need some support now. Yeah. Okay, support. Enable support. Let's make normal, no supports. Okay, that is what I expect. Oh wait, no, I want this one to be upside down. So that we only need supports for like the thing that grips the connectors. Okay, so that's gonna be 30 minutes. That's probably enough time to both mess around with the test prints that we just got off. And if we need to waste some time, play some League of Legends. 37 minutes, actually. Okay, cool. Let's go with that. We don't need a bed level. Bed level's been trustworthy for a while. It's actually never been not trustworthy for me. It's always been pretty damn good with the bamboo. Yeah. If you're hearing me bamboo, I'm saying that I think you're good. Please sponsor me and give me 50 free printers. Ah, fuck. Where did that piece go? Alexa, lights on. Alexa, set light to bright white. I lost the fucking piece. And I have to find it while wearing a bunch of VTuber bullshit. Here it is, I found it. But it's hard to get to because I'm wearing a bunch of VTuber bullshit with this like full body tracking. Okay. Oh, I'm back. I found the thing. We are back in business. Where the fuck are my needle nose pliers? Okay, anyway, let's just try to grab this crap off. Oh dear, it's not coming off cleanly like I hoped it would. I don't know, it might be one of those things that like just is kind of nasty to deal with at first and then comes off cleanly. But there's a good chance it's not. Well, maybe there's a chance. I could also just kind of try to push it out of that little hole that was intentional for pushing stuff out of. Although more so intentional for pushing the magnet stuff out of, not the support stuff. But at least this is the only support that I have to deal with right now. Fuck. I'm pretty sure I also dialed in some like easy to remove PLA supports. Okay, I'm gonna cancel this print actually because you just look up what that like easy to remove supports thing was, because if this is gonna be a really fucking annoying thing right now, then okay, bamboo PLA easy to remove supports settings. Let's Google this bullshit. 0.4. Let's make this like 0.6. Actually, let's make it like 0.9. And support interface layers, let's make that like 4, so it's like nice and thick. Wants to tear the fuck off in one piece instead of like 25. Okay. Let's go with that. There's still work to do to get rid of all the crap in here, though. I think if we can hammer out that one bit, life might be a little easier, or we might destroy this little tiny print. But at least it's a little tiny print. That was weird. the sauce. Oh yeah, that removed a good, nice chunk. Pretty cleanly. There's only like a little tiny bit that looks problematic on this. Oh yeah. Okay, I'm being weird. But yeah, that looks like it cleared out a decent chunk. Okay, I think this is a bit that I cut out with a magnet. Let's see if it slides in and looks normal enough. It's kind of ugly, but it'll work. I hope it'll work, because that does look like I tore off a bit more than I planned to. It works. It's ugly, but it works. I'll take it. Okay, let's do the rest of this. Let's see. Hold on. I am resizing my windows. There we go. Okay, cool. You also could just round this out with like some, you know, bullshit. But that also did feel kind of long. What happens if we put like a shorter bit in there? Okay, that feels more natural to me. At the same time, I feel like there's a little bit more that we can probably carve out. Is there? I don't know. Let's just... This actually would have been a good use for like some of the O-rings just to keep the magnets in, but oh well. Okay. Let's see. What was I doing? My hands are irritated, which is not good. But this is sticking as well as the stock OMNIFIXO stuff is, so I'll take that as a win. We do need to put in those heat set inserts. Okay. Let's get this out of the way so I can actually do stuff. I think first let's ream out. Let's give it a little ream job. You're not 4mm. You're not 4mm. Oh my gosh. Okay, let me clear all this bullshit out of the way. 2mm. 1.5mm. Take the saw and put it on the other side. Not this thing. You there. Hammer thing-ass thing here. We're not even soldering today. I was just demonstrating a soldering iron without actually using it. Okay, I think we're at a scene-ish. What the fuck happened here? Whatever. I think maybe I'll just straighten that out. But, okay, my hex bits. Here they are. I believe you're 2.5. Let's take the drill. Do drill things with it. Actually, yeah, that was not a bad idea to straighten this out with. It actually popped out the stuff that got like really messed up-ish. Okay, but let's go put this heat set insert here. I do have a proper heat set insert pack that I should use wherever the hell I put it. Not in there. Oh my gosh, where did I put it? Oh, it's up here. Okay, so M4, it's a little loosey-goosey. Oh, even more loosey-goosey. That's pretty solid. Loosey-goosey as fuck. Not you, not you, not you, you. Nope, nope, nope. Okay, just the tip is this one. Going down to like what, 230, I think is probably a good soft spot for PLA. I'm just waiting for it to heat up and pushy, pushy, push. There we go. Then, do we have any remnants of the freezy freeze crap? I think we do. We don't. Oh, we do. Okay, whatever. This might tighten it up so we can actually put, like, some, Well, first let's see how this actually spins in. It does not spin in. Okay. So let's take this and let's spin it out. And then let's spin it in from the reverse side, which tends to be pretty good at pushing shit out that we don't want to be in. It does have the side risk of heating stuff up, however, we don't want to heat up the foot. There we go. You see that little chunk that flew out? Alright. Cool. Then, just because it's funny shaped, let's just make sure that the spring still fits. It does still fit. That is good. Okay, so let's make sure that our little magnet guy still fits the way that should. We don't even need the exact magnet. We just need a magnet that the end can fit in. Wherever the hell that is. Here it is. Here's a magnet. Yeah, that does not want to fit. Okay, so we gotta clear that little bit of stuff here. I wonder what's the best way to do this. Maybe chisel it out-ish? This is more post-proc than I expected out of this crap. Because, yeah, these flush cutters are not fitting in easily. I'm getting some little bits out, but I'm not bullish on it. Okay. Maybe let's take one of the, knifey tips. And just kind of smooth it out with that. stupid, but whatever. Okay. Does this fit now? It does not. It's like, oh, wait, well. Nah, that's stupid. It does not fit. But there's only a little bit that seems like it's actually sticking out, though. It will pop out if it wants to. Oh, I've got an idea. We could actually have a sacrificial metal bit that we heat up. And no, it will demagnetize, but it will also deform what we want to deform. I think that is a Pogger's idea. Let's go with that. Let's set this to 300 degrees Celsius. Now I can see that. Where's the sacrificial PLA piece I can use to test that this is really the temperature it needs to be to contribute to my agenda? Or maybe I just go vibes based off of time. Are you... well, it doesn't matter. You're close enough to the family of plastic. Okay, cool. Okay, let's assume that that is now at a thermoplastic, a 3D printable thermoplastic, manipulatable at temperature. Oh yeah, that's the shit. That's exactly what I wanted it to be. That is exactly what it should be. Okay, now that is nice and chill, and we can extract it off. Maybe. But yeah, I think that is now... not quite, but close enough. Okay. Plan B, let's just carve the plastic around it. What time are we left on the print? We're at 20 minutes left on the print, by the way. Okay, so what I'm thinking is that, oh wow, the magnets actually want to stay in. That's a good sign, though. Where's the push tools that I was using? Here's one. Actually, the fact that it's hard to push these out is an extremely good sign. I'm not mad about that. But yeah, I guess we can take that. And then we can take this and you just like kind of like melty melt some stuff around it. It's a little awkward, but it'll work. Kind of like that. Oh, that can work. That can work. As long as it sticks on, that's what we want. But yeah, and let's make sure that we didn't actually mess up that we did not. That is good shit, Pecco. Ah, fuck. May have just pushed out the magnet by accident. Oops. Yeah, we did. We need to recarve it. Yeah, the problem was that I put, like, the screw thing in place, and then it was like, oh yeah, by the way, we need to go fuck over your, thing that you just secured in place, and it's like, ah, damn. Okay. Well, let's freeze-ray this and see if it does not peel off. But I do pretty desperately need to buy some new, what's it called, spray duster now. Okay, so note to self, don't do this by drill, do this by hand. Okay. So we have these other bits, though, that are a lot less dramatic to work with. Motherfucker! Okay. Ah! I just lost it. Okay, I got it. We're so back. So what's the top of this again? I think that's the top because it has the, fillet on it. The microscopic fillet that no one else is gonna see. Okay, and then we have our slidey bit. And then, was it, we have our, springy bit here. Fits in, just as we hoped it would. And then, this is something that we should definitely do by hand, based off of the thing that just happened earlier. Where is my, hand driver for that, though? Unless I'm just gonna spin it with my fingers before... Well, I found it now, I think, maybe? Yeah, I found it. 2.5 millimeters, that is what we wanted. Just gonna do fingertip tight, and then assume at the end of that, oh no, we pushed out the magnet, fuck. Yeah, that's what I was worried about, is that we'd be pushing out the magnet from the housing that it's supposed to be staying in. But at least that means that we only need to reprint the bottom half, yes. Because other than that, we have something decent enough going on with this. To where we could be like, okay, let's do that, and let's put wires up to here. And this is what the intention of the project was. Though now I think about it, that should actually be TPU and not PLA, so that we got a bit more grip. Hi, what's up? Whee! I guess you finished streaming. Oh, why is my face not tracking? Face, where are you, face? There we go. Face is back. Okay. Have to redo that one. Print. That is annoying. But if those top half pieces can't even be, like, ABS or PLA, if they have to be TPU, which means that they don't work with the AMS, then... yeah. Holy shit, it's 11 PM already. Wowie. Okay. Probably makes sense to make this a two-parter, I guess. Or at least we got the concept down. I can just report about it in after report. But yeah, I think we got the general premise of what I wanted to make working though, because like, yeah, you got this bit here to hold simple PCBs, and just a single one is doing a better job at it than like one of these guys. So yeah, could adjust those tolerances a bit so it stays a bit more vertical. You know, that may have actually been a reason why that one guy that designed the way that they designed it made it enclose the entire cylinder. But at the same time, you could do the same kind of thing just by tightening up the tolerances on that cylinder. But yeah. Okay, I'm being weird. Okay. Yeah. But I think this is a pretty... okay, I thought that we'd have 8 millimeters of travel, though, not... it's like 4-ish. But that's easy to adjust, but just by changing the distance of that. So let's go adjust that. Now. Okay, yeah, I don't get it, because... I know what's going on, We over-tightened it, to the point where it's actually touching the magnet, and it should not be doing that. There we go. That makes a lot more sense. So, yeah, it actually wasn't a design error, it was an over-tightening error. Well, you know, that actually might mean... No, never mind. The design is impossible to do it in that way. Okay, so... how should this work then? I also now know that that layer is way too thin. This might be something that needs to be printed sideways, actually. Could try that. At the same time, could also just use those magnet bases that, like, have the donut hole in them, but... let me think. I thought this was a simple enough problem to solve in a single stream, but that is clearly not true. So I think that part 2 of this should be in another stream, and we have already demonstrated functionality on the current prototype, so yeah. And I've also been streaming for 4 hours. And I want to eat some hot dogs, so, yeah. I'm sorry, but hot dogs come first. Alright, well, I think I'm actually going to, do a part 2 of this. I thought it'd be done in, like, a single stream, but, my experience should have told me better to quadruple the time estimates. But, yeah. I'll go order, probably some countersunk M4 or M5 screws, and, those donut-shaped magnet things, so I don't have to worry about this holding the magnet in place with some, like, 3D printed bullshit stuff. But, yeah, okay. Yeah. Alright, well, I think that sounds good. Okay, well, we did make V1 of these little sidey things, and 3D printing is considered in the family of rapid prototyping for a goddamn good reason, because you're not supposed to nail it on the first time. And 3D printing is supposed to be, in the sense of industrial stuff, basically instant. And by basically instant, I mean, like, 1 day is way better turnaround than, like, what, waiting for some factory to make it and then ship it over, and it's gonna take like a week and, like, $500 or some shit. So, yeah. Rapid prototyping. This is working exactly the way it should. Okay, so I think I'm gonna schedule part 2 of this for next Tuesday. I just need to remember to order the magnets and for screws that are countersunk for this. And then I think that we should probably get a usable end product from the sense of thing that I'm going to use, although I would also probably put this on my store because this is really useful. But yeah, okay, well, I'm gonna eat some goddamn hot dogs and or taco bowls, I don't know, one of those, but yeah. Alright, and I'm gonna play League of Legends. But okay, cool. Well, I think that was a productive stream. So, yeah. I am going to switch into office mode out of a formality. Whee! I am here. I am full body I'm all, oh wait, I took my Crocs off. Can you put them back on? My tracking Crocs. My special tracking Crocs. Okay, my tracking Crocs are back on. Okay. Yeah, okay, I'm gonna make some glizzies. And we made some good progress on this 3D printing stuff. And I learned that cutting magnets with a hacksaw sucks, and I shouldn't do it. But yeah, okay, well, I think this was a productive stream. Made some useful things. You know, I might also just add some, like, what's the dandelion color, I guess? Like that, whatever, like, orangey, yellow color is. Yeah, I think dandelion is the color for it. Yeah, I'm gonna order that too, just so it fits the, OMNIFIXO. But yeah, okay. Well, alright, I think this is a good stopping point. Okay. Logging off. Bye-bye. Take care of yourselves and eat a lot of glizzies. I am logging off. Bye-bye. And if you're on Twitch, I'm gonna figure out how to raid, so don't quit yet. Yeah.